Hello, this is Chuck Bejan, and I'm going to take you through a code walkthrough of the code for TPS5, which is the latest code for the trivial port scanner. A couple things that have been added for this version over the previous version, TPS3, are the addition of an additional mode called rscan here. And in that mode, it's kind of a combination of the SynScan and the trace route. What the rscan mode does is it performs a trace route to the target and then performs a SynScan on each host in that route. I've also changed the code a bit to limit the input to a set of values. For example, these are called choices. And in this case, for mode, there's only three possible modes, SYN, trout, or rscan. And that's what our choices primitive does, is that if the user enters anything other than one of these three valid values, Python will flag it as an error. So that helps out with our error checking on the input. Another option that's been added, and this is an optional argument, is this argument for randomization. This argument, short form is -r or --random. The user could specify whether or not to randomize the order of the ports in the port scan. In other words, if I was going to scan ports 80, 81, and 82, I might want to do 81 and then 80 and then 82. Okay, kind of mix up the order. The reason for that being is that a sequential port scan is more likely to be detected at the target, that the target can determine that they're being scanned. So if we randomize the order that we are scanning the ports, we are less likely to be detected. And again, this is just a simple yes or no flag. So we use choices here again, with just Y for yes to randomize and N for not to randomize. And the default is no randomization. To see how the randomization of the ports is performed, we have a new method called buildPortList. And this method builds a list from the starting port specified by the user to the last port specified by the user. It creates a sequential list of ports, and then if the randomization flag is set, it runs through those ports, each port in the list, and randomly swaps it with another port in the list. So these ports the order keeps getting jumbled around as we go through the list. And by the time we've completed our run through the list, all the ports are there, but they're in some random order. We print out the resulting list to the user so the user can verify that yes, in fact, they have been randomized, and yes, all the ports that the user wanted to scan are there, and they will be scanned. Moving further down, I do want to point out that the SynScan itself has had a minor modification, and that being in how we report the results. Previously, when a port was open, previous versions of TPS would just, if port 80 was open, it would just put, port 80, just the 80 is open. However, it would be more helpful if we actually knew what that port 80 was, what protocol that usually serves. And so now this code here, which is this sprintf call, and this syntax here will actually format the S-port field of the TCP part of the object. And now we do print the protocol. So instead of just seeing 80 as the open port, now we're going to see 80 and HTTP. or 443 in HTTPS. All right. Our next modification is the actual code to run the route scan, which is that trace route followed by the SYN scan on each host. We start off by putting a divider here. We run our trace route, and this gives us a route, a set of hosts to our target, and then we cycle through each host and we run a SYN scan against it. Very simple. One last thing compared to the previous, you notice we've added rscan here as a mode, but also the error code that we had in here before, the error checking code that we had for taking care of the case where the user entered in invalid mode, we notice that error checking code is gone. And the reason that we don't need that anymore is because we went to using the choice primitive up here when we specified our arguments. See, our choices. We specified our arguments. All right. And that's our code walkthrough for today.